This is the agenda for a few things that I'm planning to cover today, just to walk you through what it's going to take to move your application to the cloud. And once you're actually in the cloud, how do you make sure you stay there? How do you make sure you're secure? How do you make sure you're highly available? And how do you make sure you're resilient to any kind of disaster that might strike your systems? So a quick overview on who we are. And our mandate's quite simple. What we found for a typical engagement on our side, in 5 to 15 days, we can help cloud enable your application. We've been around. We're a small company, a small division of a large company, I should say. We've been around for 10 plus years in this space. We've about 500 plus trained people in the cloud. So we've been doing this with Amazon Web Services for quite a while. We've got, from a development organization's perspective, CMMI level 5. From a network operation centers that we run, there's ISO 27001, which makes sure that we're compliant with a lot of the security and the security policies and the best practices out there. I'll walk you through a little bit on a case study with a $1.5 billion ISV that we cloud enabled on Amazon. So how we helped take that ISV's application from what used to be an on-premise deployment to the cloud, and once they were running there, how we made sure that they stayed over there. We've supported over 5 million hours of uptime now on Amazon, collectively across the instances that we've been managing. And we have 5 network operation centers around the world. We have 2 in India, 1 in Germany, 2 in the US. We've been working with several blue chip companies over the past decade or so. Of late on Amazon Web Services, either directly or through partners of ours, today we are supporting customers like Bank of America, Blue Cross Blue Shield, ING, Cardiff, Kraft, Warner Brothers, and a whole bunch of others. So just a real quick overview on why the cloud makes sense. Everybody's here to understand what the cloud can offer you. So at the end of the day, why does it really make sense? Here are some points, but an interesting conversation we had with a Fortune 40 CIO went as follows. So this gentleman had recently bought about $30 million of enterprise software from a particular software vendor. So he went to a big hardware/software manufacturer, and they said the tab to build out the data center to run that infrastructure was going to be $150 million. So the CIO, he had enough money in his budget, so he looks at it and he says, that's not really going to be a problem. But the issue is that it would take him 3 years to get the data center ready before he could actually start using his application. And now, from the CIO's perspective, his bonus was based every year on the return on invested capital, and in this case, he's not going to see a bonus on this project for 3 years. The other thing he was saying is, that's great, but I need the solution on Monday morning. So what am I going to do? So his only choice at that time was to look at the cloud. In addition to the pay-as-you-go, no upfront CapEx, elastic scale, is the fact that you get agility, which can really make the difference between getting out to market on time and being a minute too late. The other big value is once you see a lot of these savings, you can pass them on to your customers. So that makes the cloud value proposition very appealing. Like the old saying goes, right? In theory, there's no difference between theory and practice. But in practice, there is. So what happens here is, let's say you theoretically assume that your usage is going to be along the red dotted line. So you assume that it's going to follow that kind of a function. That's how your users or your usage is going to be. So you procure the hardware up front for that. And the green line is life. So that's what eventually ends up happening. And what you see in this case is initially you have a lot of waste in your system. And eventually, because you don't have capacity to support your customers, you have frustration. So it's really not ideal, because you have to try to play this inexact science. It's like predicting the stock market. If you could do it well, nobody would be in this room. It's virtually impossible to do. So it's an inexact science. And with the cloud, you can really streamline your infrastructure usage based on what your actual usage needs are. The other issue that comes about is oftentimes it's easier said than done to manage your own infrastructure. Unless you are in the technology business, today, because of what technology offers, you're forced to get into it. You have to make sure that you get your systems, you set your data center up, you procure, you rack and stack your systems, and that's just inefficient use of capital. That's not the most effective use of your skill or your people's skill or your organization's focus. So what we've typically come to see is about 30% of the effort goes into your business and 70% is wasted on undifferentiated heavy lifting. But with the cloud, what you're allowed to do, or what it's possible to do, is essentially align your intellectual spend, if you may, with where your business value is actually getting created. So what does it take to build a cloud-ready application? So in our opinion, one of the most important things to understand is that it's a shared responsibility model. So it's essentially a three-legged stool if you think about it. There's the infrastructure that you have. There's the application that you develop. Either you buy from a third party or you have an internal IT organization building it. And then ultimately you have your operations. So understanding that the infrastructure today is being provided by Amazon, the other two are your responsibility or responsibility of you with your partners. And where we come in is we say, you focus on your application, you enhance your application, you build it out, you add the value, you add your features and functions, and we will make sure that operationally you have the efficiency that you will need to keep your applications running. So what are some of the design best practices that you see? Protect your data. The top 3 questions that we get every time we're talking with any person from a customer's perspective is, what is your plan for security? What is your plan for security? What is your plan for security? So that is one of the most important concerns, both on the design side as you're building your app, as well as on the operation side, which we'll get into in a little detail. You want to also make sure that, as Janki Ram was also pointing out, things in the cloud may fail, either because of a bug in your application, an instance might go away. So you want to make sure that you have designed your application to be resilient to these kinds of failures. If you design for that up front, it is possible with all the building blocks that Amazon's provided to actually be resilient to these kinds of failures. You want to make sure you handle reboots gracefully, so your application should not be so stateful that in case, for whatever reason, your instance goes away or you have to reboot or you're running some spot instances, that your application will not be able to recover. You want to decouple your application, make it stateless. This has several advantages. For example, if you have a load balancer or your application depends on sticky sessions, if you were to lose an application server from your cluster, you'll probably lose session-based data. By making your application not depend upon state, you have the ability to horizontally scale out your app. Another scale best practice, and this is not just for the cloud, is you want to isolate your traffic depending upon your usage. So you want to separate your static data from your dynamic data, you want to separate your reads from your writes, and this allows you to come up with a scaling plan that makes sense. And let's look at some operations best practices, right? Securing your systems, as I mentioned. We'll get into details on how you can do this. Amazon provides you availability zones as well as regions. So there are 7 regions across the world, each region with multiple availability zones that allow you to really architect your app for high availability. So you want to make sure that you leverage this as you're building it. The easiest thing is to say, I've got one application, one instance that's running, and if that instance goes down for whatever reason, your application's down. But if you make use of some of these building blocks by leveraging multiple availability zones and distributing the architecture of your application across those, you will be in a position to be a lot more resilient to failure. Automation is a journey. It's not really a destination, right? So you want to come up with your automation roadmap and then invest in it as it starts to make business sense. There's a lot of potential to automate a lot of things, as we saw even in the previous session. You want to put that on your automation roadmap and then set along the journey of actually doing that automation. You want to separate your environment. So in the cloud, you have the benefit of quite easily and for a short period of time setting up and standing up, say, dev test or UAT or scale test or pre-prod environments. You want to make use of that. So you actually have a relatively close mirror of production as you start to roll out applications. You want to also, like they say, not everything that is counted counts. You want to make sure that you set up your threshold so you can separate signal from noise. What should your thread count really be that you're watching and before which you have to take remedial action? What should your CPU utilization actually look like before which you can start taking action to add another instance or to remove an instance? So these kinds of things need to be thought about before so you're not inundated with false positives or a lot of alarms. And then you want to document the process because in the cloud, the iteration cycle can be very rapid. So it's up to you to see how often you want to iterate through your processes. So let's look at security, right? In a typical web-based application, let's assume that you've got a web server. Underneath that, you've got an application server. Then you've got a database, and finally, your operating system. So Amazon gives you this notion of security groups that you can set up to really control and streamline the traffic as it flows through your system. So let's say in this case, on the web server group, you want to open up your HTTP port and your HTTPS port. So 80 and 443 are open, and they're open to the general world. Underneath that, on your application server group, you can set it up in such a way that you only allow your app server ports to be open, and the only instances that can talk to those application servers are the ones that belong to your web server group. So this way, nobody from the outside world can actually come in and talk to your application server. In the same way, on your database, you set up your database ports so that the only traffic coming in and out are through your database ports and from instances in your application server group. So nobody from the external world can get in and actually try to access your database. And then ultimately, you set up your operating system, and your operating system has, say, the SSH port open. And that's only open to your corporate subnet, so only people from your corporate subnet can actually come log into that machine. So in this way, you have the ability to quite granularly control what your traffic looks like to your instances and components within those. You want to make sure that you harden your stack before you release it out, or your operating system before you release it out into the wild. And your deliverable on this side is a hardened gold Amazon machine image. So you want to make sure some of these tasks at hardening, you have to make sure that if data at rest is important for you and security is, you want to make sure that you have an encrypted file system, or in some other way you've basically provided at-rest data encryption. You want to make sure you've secured your history, you know each and every script that starts up when your system launches, and you've removed everything that's non-essential. And once you have that, then you burn your gold image, and you use that every time you launch an instance. On the database side, you want to make use as best you can of various mechanisms that your database vendors will provide. So things like transparent data encryption and Oracle Wallet in case you're using the Oracle stack. And in this way, you can make sure that your applications don't necessarily have to change to account for a secure encrypted a file store at this point, or a data store at this point. You want to make sure also that you're running your database as well as other instances on hardened images. So in this case, you have a hardened operating system on top of which you've built your stack. Supporting multiple customers is also very easy to do in the cloud. So you want to make sure the stuff in yellow is what Amazon provides. The stuff in green is what the application provides. And then CloudEnable, for example, provides managed services across the stack. So in case you have to, for example, have multiple customers, you don't have to, as a software company or a developer, necessarily build out a multi-tenant solution right away. You can start with single-tenant solutions, set up cloudlets for each customer, and have customized, so to speak, policies for each rollout. And then you can have your multi-tenant systems built over time, or if available, set up in a separate stack that can then communicate with your customer-facing instances. You also want to make sure that you've got IPsec tunnels or some sort of in-flight data security from on-premise equipment up through to the cloud and back. So what is it going to take for 24/7 SLA-driven operations? So most operations that we see today tend to be reactive in nature. You know, you're driving along as a developer and you get a call saying, hey, I can't access the website. And then you're like, well, it was working when I left the office. So you scramble, or you try to log on from your phone, or you get home and check, and sure enough, your database is tipped over. Now, if this happens while you're sitting at your desk, it's not too bad, but if it happens at 3 in the morning, you know, somebody's waking you up and you have to frantically go and try to figure out what the problem is. So that is reactive monitoring and reactive management. The better way to do this is through proactive systems, right? So if you look at it, proactive management requires you to figure out what thresholds you're going to watch, and then set those in place so when those thresholds are violated, you get an alarm that comes in. You want to also make sure that you've set up any kind of change monitoring and change management. So in case you do need to, for example, patch your application, you have processes in place to patch your hardened images, you have processes in place to patch your applications, and then continue to work in a secure environment. You also want to make sure that you've put in things like your business continuity plans beforehand. You know, the wrong time to plan for a disaster is when disaster is going on. You want to make sure that you're set up, you've got your plans in place, and when you need to execute a DR plan, you're just purely in execution mode. You're not trying to discover things, you're not trying to test at that time to see will this work. You are just going through a runbook that is now available to you, that has been battle tested several times in the past, so you have a high degree of predictability in getting back up and running. So let's look at business continuity and DR. The reality, unfortunately, is disaster is probably going to strike. It's not a question of if, it's a question of when. So you want to make sure, and this could be because of your application, this could be of things beyond your control, it could be things beyond Amazon's control, or your infrastructure provider's control. So you want to make sure that you've accounted for that. So the key thing is, like we saw in the mic case, the key thing is that you want to avoid single points of failure. So you want to make sure you've got redundancy baked into the system, and you want to make sure that your systems are tested to handle that. You want to design and test your various failure scenarios. So what is a failure scenario? A failure scenario is, as you look at your architecture, you start accounting for individual components going down. Then you start grouping those components together and start planning to see what happens if a group of those goes down. And then you work out the various permutations, and you have operational plans that are aligned with those failure scenarios that you might encounter. I think we're losing battery here. Oh, there you go. The other thing from a business perspective is you want to account for your recovery time and your recovery point objectives. So this is a business imperative that has to be thought through deeply, because you need to understand how much downtime can your application and your infrastructure survive from a business perspective. Everybody wants their systems up right away, but it comes at a cost. So is it acceptable for your system to be down for, say, 15 minutes? Is data loss acceptable? If you're a social networking app, for example, and somebody uploads a photograph and it's not rapidly available because something went down and it shows up after 2 hours, that's probably okay. But if you're a financial services application, somebody makes a deposit and goes and checks their balance, and the money's not there, they're going to get concerned. Or they take money out and you run your balance and you see that the money's not been taken out, you've just made some money. So, in certain cases, your business cases are going to be different. So you have to account for that and design your recovery time and your recovery point objectives. And the same way, you want to make sure that you handle your data backup and your data backup management plans. So how are you going to back up your data? What schedule are you going to put that at? And then how do you make sure that the encryption around that is also in place? So if you need to recover from a particular backup, you want to make sure that the backup is always secure. And then you've got your policies in place that in case you change the password, all your backups are also still going to be available. And this is the accounting for your encryption and key pair rotation. So if an employee leaves, or you have to fire somebody, or somebody is no longer with the organization, and you need to rotate your keys, or if your keys in some other way or your credentials are compromised, you want to make sure that you've got a policy in place that allows you to very quickly recover from that, or rotate your keys. And once you've rotated them, you want to make sure that everything else still stays accessible. All your old backups, say after 90 days when you've rotated your passwords, your old backups are still accessible. And you don't have an old password on your backups that you can no longer access now. And again, you want to figure out what your automation plans are, and then start putting the automation for a lot of this in place. So let's look at some of the case studies of what we work. Since we're running a little short on time, I'm just going to dive into, let's see which is a good one. So let's look at the financial services startup. So in this case, a company approached us. They had 2 instances running on AWS, and they were rolling out a stock market tracking application. So from their perspective, they said, well, we are not sure how the application is going to do. We want to make sure that we can roll it out as quickly as possible, run some experiments, but we want to make sure that the application is always available to our customers. So for them, in 5 days, we took the application and moved it to the cloud, and then we provided them at $9 an instance a month, basic managed services, so they had an insurance plan in case something tipped over. In the case of the $1.5 billion ISV, they have about 100 customers, each with about 10 to 100 instances that they're running. Now for them, there's a lot of policy, there's a lot of audit trails that are needed, there's a lot of compliance needs that they have, and there's a lot of security. So for them, what we did is over the course of several weeks, we onboarded their solution, we automated a lot of the work that we talked about over here, and then we continue to provide them as well as their tenants 24/7 managed services. So we are proactively watching their systems, and in case something were to tip over or there's some issue, we are proactively handling it and not having to, the customers not having to suffer through a business outage. And let's look at some next steps. So we've also launched, as we found that the cloud is truly a paradigm shift, we've launched a University of Cloud. So we've got training classes that we offer, and these are not yet offered in Delhi, but they're offered in the south, and the plan is to roll these out across the country. So this is where we'll share some of the knowledge that we've learned over time, and we're certified training centers for larger companies like Oracle and Solaris Technologies, for example, and now we're offering that for the cloud. So it will really help you to figure out how to build your application, how to architect it appropriately, and then how to make sure that it's, the operational efficiency in your applications and your solutions is truly present. the cloud onboarding. This is where we take the application and go through the automation and make sure that your application is now ready to run in the cloud. And then following that, there's the 24/7 monitoring and management services that we provide. So we have a booth outside. Would love to field more questions if you have some. And I think we're pretty much at time. So thank you very much for listening.